Hey everybody, my name is Matt Sokup, and I'm a Principal Cloud Developer Advocate for .NET.
And my name is Nish, and I'm a product manager for Enterprise App Patterns. Today, Matt and I are going to talk to you in detail about how do you bring your existing applications or web applications to the cloud more confidently. Every single time we go to a developer trying to understand what are the frictions that they face to bring their existing applications to the cloud, we almost always hear this. How do other developers take their first step in the cloud? Now, this is not because we don't have great resources and assets to help you get started on the cloud, but more importantly, developers are looking for a guidance which is similar to their scenario. They're looking for best practices that other developers have already taken, and they want to utilize that very straightforward so that they're immediately successful. So what we did, well, we went and built it, Enterprise Web App Patterns, and it's a prescriptive cloud journey for your existing applications to bring them up on cloud. Now, various developers are in different journey, right? Some are just getting started; those are greenfield applications, but some want to bring their applications to the cloud so that they don't want to use on-prem anymore, and they want to stop there. That's where they just converge and stop. But there are some developers who want to take their application further ahead and then make it cloud native and go to the microservices world and so on. So Enterprise Web App Pattern is going to be is defined as a journey. It starts with the first pattern, which is the reliable web app pattern, which we're going to talk about it today. Now, reliable web app pattern is where you apply this pattern to your existing legacy entire web app so that you can converge them on the cloud very quickly with making minimal changes. Now, again, we're not talking about the lift and shift scenario to like spin up the same sort of configuration on VMs on the cloud, but we are talking about developer changes that needs to be applied on your code that will help you set a foundation for all future modernization in the cloud. Now, when we build this pattern, there are certain principles that we went through. We stick to the Azure well-architected framework, which is a well-defined best practices under Azure Architecture Center. It goes through various pillars, and we do apply the developer patterns called out in those pillars as well. We also stick to the 12-factor app principles. We talk about .NET today, but there is also Java. If you're someone or if your team is interested in that, you can take advantage of that too. We are a developer productivity company, right? So we pay attention to how we can make the developers successful. So we have also implemented Azure Developer CLI so that you can quickly take your code to cloud for developer scenarios. And then further, we have also included the CI/CD configurations for specifically for dev as well as the prod scenarios, which are completely different, right? And because you're on the cloud, there is various moving parts. You need to observe your applications in a holistic way. So we have implemented observability, and also the other important aspect that we almost always hear from every developer we talk about is like, how much does this cost? Like, how much does it cost to run this on Azure? So we made that very transparent. So you should be able to look at it. What for this architecture, how much would it cost for dev scenario versus the prod? And that's where I come to cost optimization. So we even talk about cost optimization, where the developer environment shouldn't cost you much versus the production, because production you would choose a certain SKUs that are more important for meeting your SLOs. Now, talking about SLOs, we even defined an SLO like 99.9%, similar to most of the customers would do, right? When they want to bring their businesses to the cloud, they want to make sure their important flow in the business is always up and running so that they don't lose customers. We even paid attention to that. We defined that. And in this case, we did make sure that it is a 99.9% SLO. So then we have to go and implement multi-region. So you can look at how this multi-region based architecture is also defined. Again, multi-region is not required for your for your developer scenario. So we avoid that and we only optimize that cost for production. Now, there are various other patterns that we implement here. And because this is the first pattern that where we're bringing our applications to the cloud, we implement a couple of important developer patterns that we believe are essential to get your applications running in the cloud and also have that cloud thinking, right? So When it comes to on-prem, let's say when there are failures, either the box entirely fails, there are people who could look at that infrastructure and get it up quickly, and then the entire application comes back. But when it comes to cloud, what happens is you're working with multiple different services. For example, you will connect to a databases, you'll connect to Redis cache, they're all in different boxes. You'll connect to say telemetry, logging, and other things where there are services which will have some sort of an intermittent failures, or you may have dependency third-party services, and it may fail for a certain amount of time, but then that doesn't mean that the application cannot execute the other task, right? So you want to ensure to implement resiliency, for example, implementing retry and circuit breaker design patterns, which are important aspect when certain services are going down. You can wait for some time before you call it an error, right? So those are the patterns that are most important when it comes to bringing your applications to the cloud. Now, those are the demos that we have it for you today. Matt is going to take you through all those aspects today. We also talk about cache aside pattern. Who doesn't want performance? Everybody needs performance. So if you want to improve the performance in the cloud, there are patterns like cache aside that you can implement so that all those important important workflow in your application, they can be those data that doesn't change often can be cached so that those areas are highly performant. Now we show about implementing how do you implement cache aside and so on. We talk about Azure Active Directory, to basically manage identity. How do you use private endpoints? How do you expose application only to the endpoint that is needed through the web application firewall, and so much more. And today we would not be able to cover a lot of this aspect because of the time constraint. But then today we'll talk about certain developer patterns which are more important. And then you can go ahead and take a look at the other implementations. For example, centralized configuration. How did we do managed secrets? How did we do private endpoints? Or how did we do resource tagging? What are the best practices for bicep implementation for immutable infrastructure and so on. Now, I want to, before I pass it on to Matt, I want to tell you this very clearly that this is a production grade application, and we have learned from various other customers, partners, and also how Microsoft does things, right? So we have baked in all those best practices so that you don't hit those failures in your journey. Now with that, over to you, Matt. Show us some demos.
All right, thank you very much, Nish. Yeah, so let's get started with our demo. We're going to be talking about something called Relay Cloud Concerts. Now, this is a demo application that we packaged into the overall reliable web app pattern. And what's great about this is that it's production ready, meaning that if you really wanted to reproduce a concert ticketing application and push it out in the cloud, you can, right? It's good to go. But even better, in the code that we provide to you, step by step, best practices in the code and everything else are there for you to essentially copy over and make applicable to your application. So let's go ahead and take a look at what we all have here. So the reliable web app pattern overall is divided into 5 different pillars: reliability, security, cost optimization, operational excellence, and performance efficiency. So what we're going to concentrate on in this demo specifically are the reliability pillars and the performance efficiency pillar. Now, reliability means you want to keep your app up and running even when weird things start happening. So think about reliability as your app, when it's in the cloud, might have to make calls to other services that are also in the cloud. What happens like one of those services go down? Maybe they're having intermittent troubles. You want your app to not crash just because some other service happens to be down. And if that other service goes back up, you want to be able to recover seamlessly. So that's what reliability is all about, making sure you're resilient and can handle intermittent failures. Performance efficiency, as you guessed it, is making sure that you're fast, and that you're not only fast, but you're fast at a way that's also cost efficient as well. So then we have security in there, cost optimization, and operational excellence. And if you go out to the overall reliable web app pattern, and I'll put up a URL for that in just a sec, you can find out more information about those. But this is .NET Conf. We're going to concentrate in on code, and so reliability and performance efficiency are where we're at. So you can get the code aka.ms/EAP/RWA/ .net. Somebody got happy with the slashes. That was me, aka /.net enterprise app patterns /RWA reliable web apps /.net, our favorite platform to be writing apps on. So let's jump out to the code and see what we're dealing with. So what I'm going to do is I'm actually going to go ahead and open that up, aka EAP RWA.net, and what's going to bring me to is a GitHub repo. So let me make that a little bit bigger. And so what we have here is all the code that you can get. We'll also be able to go to and browse some documentation. And then there's even videos and workflows on how to install the app and everything else. So everything, this is your one-stop shop for the reliable web app itself. And here's some documentation that you could read and everything. All right, so you're not here to learn about this. What you want to see is the application in running. What it's all about. All right, so let me jump back to the home page here. So here's Relay Cloud Concerts. And so what we wanted to do with the reliable web app pattern with Relay Cloud is we wanted to create a scenario where it'd be kind of applicable across different, I guess, business domains. So no matter what you're doing, you can understand how we applied it, and maybe it's even applicable to what you're up to. And so what Relay Cloud Concerts is, imagine that it's a call center and people are calling up and they want to order concert tickets. So you can go through and you see, all right, Larissa Sevilla has a concert available and you want to add it to a cart. All right, add it to the cart. So it's essentially a shopping cart. Great. That's really what we built. You can go through and you can check out. I would have to sign in order to check out, and so on and so forth. So that's what we built. Let me see, I checked in, agree to some scopes. So very good. And here where everything is, you can see that I'm actually right there. So the first thing I want to do then is I want to take into account, all right, the upcoming concerts, that's a separate API service from this web service. So let's take a peek at the code. I have a web app and an API app. The web app is obviously the user interface. It calls over to the API app, which hits the database and brings me back the concerts. It can bring me back my tickets that I have stored and so on. So I want to make sure about the resiliency portion. What happens if my API, for some reason, is deployed to a different app service? What happens if that goes down? I want to make sure that's resilient and up to date. What you want to do is you want to implement something called the retry pattern. And so the retry pattern does it, if it hits what I'll call a error that's transient and might come back, the retry pattern will say, all right, let's try again, but let's back off. Let's not try again immediately, but let's try again. Let's say you hit it once, and then the next time, let's try again a second later. And then the second time, if it's still down, let's try 3 seconds later. And so that's what the retry pattern is all about. And you can do that through 2 different ways. You can do that through either a lot of the Azure services, so you can even apply the retry pattern to things like Azure SQL. So a lot of the Azure services have retry patterns built into themselves. And one of the things the RWA specifies as a best practice, and that's one of the great things about RWA that I didn't really hit on yet, is that it's best practices and it says, do it this way. We specify that if you are using some Microsoft provided SDK or Azure provided SDK, and it has a retry pattern in it, the ability to implement the retry pattern, use that. So here, when I'm doing up my database context, which has essentially we're just using an entity framework, I'm saying, you know what? Use the retry, maximum 5 times. If I'm having issues contacting my SQL server in the cloud in Azure, try it 5 times. Delay, 3 seconds, and if it's good, if I can do that within 5 times, great. If I can't, give up and throw the error. So that's what's happening here. So if we have issues trying and failures, and the SDK has it, use it. Now, sometimes you might not have built-in SDKs to handle retries. And that's where a library called Poly comes in to help. And so let's explain this just a tad. And so what we're doing here, and this is in the web app side of things. I have a whole bunch of things here, functions here called add ticket purchase service, add concert search service, add ticket image service. And what these are essentially is that they're just throwing over into a class an HTTP client. So each one of these service classes will get a client, an HTTP client. And so that then, these service classes then are responsible for calling out to the API. So purchase ticket async, it's using the HTTP client that got sent to it, and then is just calling out to like API ticket purchase. That's its job in life. All right. So if I go back here, what I'm saying then, I'm attaching to this HTTP client, I'm saying, you know what? If you have issues with things, let's start using Poly. Let's use this get retry policy. And what we're saying here then is we're adding a delay to it, which is it's actually doing a very, I'm going to say just a fancy delay, saying decorrelated jitter back off. And it's saying from 500 milliseconds back off further and further away for 3 times, and only handle transient errors. And what a transient error means, something that you would expect to come back. In this case, it would be a 500 error. So 500 errors sometimes appear and disappear right away, or a 408 error. And then wait and retry async. So we're attaching that Poly retry policy to it. And then right along with retry errors, there's circuit breakers. And so what a circuit breaker is going to do, it's that after we got to our 3 times, it's like, all right, stop. We've had enough. We don't want to overwhelm the service. It's down, give up. And that's what a circuit breaker happens. So you always want to do, when you're doing a retry, you always want to attach the circuit breaker to it. And that's what we're happening over here. Just saying, you know what, on the handle transient error or a 404 not found, 5 errors within 30 seconds, throw a circuit breaker at it. So that's what this is up to. Let's actually see this in action really quick. Now I said it's all production ready code, and it's almost true. We've implemented something over on the app config side of the web API that lets us say, throw an error on every so many requests. So it's not necessarily, it just lets us try out these patterns. And so if I go into the Configuration Explorer and I do a create new key value, I believe it's called API app retry demo. And if I give it a value of 2, it's saying every other request comes in, throw an error. So I'll do that. I'll put that in, and then I'm going to jump back out to the resource group, open up my API, and then I will restart it. All right, so it said it successfully restarted the apps, but we'll give it a couple seconds to actually go through, because sometimes it does take just a tad bit longer than what we would like, and we should be good pretty soon. So while that's happening, what I am going to also do is open up Application Insights. And Application Insights has live metrics. Request failures, great. So let's go back to the main Relay Cloud over here. If I go over to upcoming, I'll refresh it. It should be hitting the waking up the API. All right. And so if I keep on hitting refresh then, you can see I started getting errors on the second time. Hit it again. So every other time I hit it, I get an error. But the good thing is, it stays up. My application doesn't blow up on me, which is awesome. It's resilient because of the retry pattern. Now, if I was going to go out and change the app config value for the retry demo to be 1, where the error would happen every single time, then we would make the circuit breaker trip, and we would not blow up, but we would then gracefully fail over here. Okay, so one thing I did want to take a peek at before we jump over to performance efficiency. Take a peek really quick at all of the services that we have deployed in Azure for Relay Cloud. Now, I mentioned that it's a full-scale production-ready application. We have an app configuration, a whole config values, 2 app services, the app service plans for each of those, Azure Cache or Redis, front doors, a key vaults, and managed identities, a bunch of network interfaces. We have a private DNS zone, a ton of things. In fact, what it looks like is this. It's the real thing, right? It's what you would actually do if you were deploying to Azure. So we didn't skip any steps, like if you were deploying to Azure to production. So the first thing, what I saw when I saw this architecture is like, I don't want to do this for a sample. New up individual app services, a blob storage, DNS zones, all that, just to do something like this? Crazy. Luckily, you don't have to. And what we've done to help you out with that, because it is a sample, right? And you can run this very easily, is that we've created AZD templates for you to deploy everything with. You would go to the home directory for where you clone the repo from, and then all you would need to do is just do AZD provision, and it'll run. Actually, we have all the steps to walk you through that. So you actually have to init AZD first to give it essentially a resource directory name. But once you get here, what it does, when you do AZD provision, it runs through these bicep files. And these bicep files, then all of these over here go through and actually provision all the files, all the resources that you need. And here's what's cool. You can see right up here, like param name, location, principal ID, whether you're deploying to production or not, you're passing those into these bicep files like parameters. And then like if you go over to resources, you can see things like we're creating the key vault. And when you create the key vault, we're actually creating roles for the key vault as well. So you can get really fine-grained into things. And if I go even to like Azure Redis Cache, and this is actually super cool, right here. This is where I am creating the Redis Cache instance. But if you'll notice, I'm figuring out what the SKU name is, whether it's standard or basic, based on the variable that's passed in, the isprod. So whatever that happens to be, whether it's true or false, determines whether my SKU is standard or basic, so I can determine the pricing that I want. So if I really wanted to, if I was deploying for production purposes, I can do a standard SKU. It's more beefy, can handle more. But if I'm just doing development, make it basic and have it roll through that way. And AZD, the Azure Developer CLI, not only would provision all our resources, it can actually deploy all our resources as well. And it does that, and I'm opening up right here azure.yaml file. So also within the root directory of the reliable web app pattern, which you would clone from GitHub, and it's saying, all right, for my web service, deploy relaycloud.web. For the API service, deploy relaycloud.web.api. And so it knows enough to deploy those two things, because when it creates the web apps, the web services in Azure, so I'm opening up the API, it's going to take it. So it says AZD service name, API. So it says API, it matches that, and then deploys the relaycloud.web.api. So you can deploy to just app services, you can deploy function apps, you can deploy to Azure Container apps, tons of things. Very powerful with the Azure Dev CLI. So a little sidetrack of how we deploy everything, so you don't have to worry about newing things up and deploying, right-click deploying yourself. AZD, we cover all that in the README to help you deploy it. Now, performance, efficiency, I promised that we would cover that too. All right, so let's go back to Visual Studio. Okay, covered Poly. Now let's get to performance efficiency. So one thing it's called a cache aside pattern. And so what the cache aside pattern does, so let's say, and we do have, we're calling out and we're grabbing a bunch of concerts, right? So let's pull that back up, Relay Cloud Concerts. So when I go here and I grab my upcoming concerts, this data, it doesn't change a whole lot, right? The upcoming concerts are the upcoming concerts. Even, Aiden Hunt, that concert, the City Warriors Tour, that thing has been going on for years, right? That's not going to change. So this stuff is all going to stay the same. So why wouldn't we cache it, right? So we wouldn't have to hit the database over and over again. We hit the cache, it's going to return faster. So how do you do that? You do it via the cache aside pattern. And so I have it implemented here. And there's a couple things that you have to do in order to implement it. And in the SQL database concert repository, which is just a class that essentially wraps the database context to pull things out. So it's wrapping the concert data context, which is entity framework. And so the first thing I want to show off is, let's look at the Git. The Git upcoming concerts async. So the main page that pulls this whole function right here. So what happens is very first, it has a cache that this iDistributed cache actually gets injected into this overall class. An iDistributed cache can be in memory if we wanted to, but in this case, it's actually a Redis cache that gets put into here. So this gets injected. And then what we're saying here is, you know what, if there's anything with this key, upcoming concerts, pull it out into this string. And so we know that it's going to be in JSON because that's the way we're doing it. And so if it's not null, deserialize it. So if we already have it then, if it's already deserialized, return it. Boom, we don't have to hit the database at all. But if there's nothing in there, grab it from the database, serialize it, cache it up, make some an expiration date. That way, 1 hour from now, just in case Aiden Hunt does change the concerts and it expires, and we do have to pull it out, and then put it into the cache, and then return it that way. So if it's in the cache, grab it. If it's not in the cache, grab it from the database, pop it into the cache, and then return it. All right, so that's Git upcoming concerts async. Now, let's say we have to create or update a concert. So the key for the cache aside pattern here, and the cache aside pattern means it's faster, but you also have to take care of your data too. You have to keep it up to sync between your database and your cache. And so the way you do that is we're creating a concert, right? So we have a new concert coming in. And so you update the database first, right? Pop it back into Azure SQL. Then what you're going to want to do is you remove it from the cache. Invalidate the whole cache. Just say, you know what, everything here is bad. You actually just say it's gone. Remove the whole thing. That way the next time you get all the concerts, you're just pulling everything out new again. There's not going to be anything in the cache, so it's going to go hit the database and populate a whole new thing into the cache. Same thing with update concerts async. Does the exact same thing, except your database is a little bit different. Delete concerts async, same thing. Goes through, finds the deleted concerts, and then moves it, and then removes it from the cache. All super, super neat. And that's really how you implement the cache aside pattern. All right, so we went a couple different places here. We started off looking at resiliency and how the retry pattern retries a couple different times to make sure that we didn't have any transient failures on any web services that we called. We also looked at circuit breaker, where circuit breaker said, all right, we're not going to retry forever, give up after a while. We took a peek over at bicep files at AZD and how we have the whole provisioning taken care of for you, and also how you can use that in your day-to-day work scenarios as well to deploy and provision Azure resources. And then finally, we took a look at cache aside pattern, or how we can speed up our web applications by using Azure Redis cache and put things inside of that so you don't have to hit the database over and over again. So those are just some of the best practices that we include with the reliable web app pattern. Well, thank you very much. I always love talking about reliable web app patterns. I hope everybody else here enjoyed it too. So just remember 5 pillars, all the code that you could ever want, and everything else over at aka.ms/eap/rwa/.net.